Hi everybody. Today we're going to go ahead and do day 4 of Unit 6. So we've already finished everything with exponents, and now we're going to go ahead into radicals. Disclaimer, sorry if it's a little noisy in the background. I'm now by the AC unit, so I can't turn that off. So I'm going to try to be really loud for you. Beware of headphones. Alright, so how do we simplify non-perfect squares and non-perfect cubes? So when we're talking about radicals, we are talking about simplifying them. And with perfect squares and perfect cubes, we can just simplify them to be a separate number, like square root of 36, 6. Cube root of 27, 3. But with non-perfect squares and non-perfect cubes, it's a little bit more difficult. We still need to simplify them, but we don't have just like a whole number. And we don't want to use decimals for this. So instead, what we do is we actually go ahead and do prime factorization. I have no idea why this is way over here. And the way that we do that is with a birthday cake. So I know it sounds really weird, but it's really not. In order to do prime factorizations, what that means is that you're breaking down a number into all the prime numbers that you would multiply together to create that one. So we do that, and then that way we can pull out numbers from the radical that are perfect squares and perfect cubes, so it makes the number under the radical smaller. I know it's a lot of words right now. Let's do a quick review about what prime numbers are. So prime numbers are numbers that are only divisible by themselves and 1. So 2, 3, 5, 7, 11, 13, 17, 23, all those are prime numbers, and you will use them for prime factorization. Now, the most common ones you're probably going to use for this, like most of the examples you see, are like 2, 3, and 5. A lot of numbers can just be divided by 2, 3, and 5 multiple times to create the prime factorization. Okay? So here's an example. Let's try to find the prime factors of 36. Now we're going to use the birthday cake for this, and some of you might be a little familiar with the method that we're doing, or at least the goal of what we're doing, because you guys have probably done prime factor trees before. If you want to use prime factor trees, you are totally welcome to. However, I just find prime factor trees very messy in my mind, because then you got branches going everywhere and you might miss one. So I don't like using them. I like using the birthday cake, and here's why. So to do the birthday cake, you start with the number on the bottom and you kind of create a layer of cake around it, a tier. And you just go through them and ask yourself, okay, what prime number can I divide 36 by? I always start with like the smallest number, which is 2. Most numbers, half the numbers out there, because they're even, are divisible by 2. So I always start with 2. I didn't want to put that red thing there, so ignore the red thing. But 2 goes into 36, so I go ahead and divide 36 by 2. I get all the stuff that's not supposed to pop up. I get 18, and I create another little tier around the 18. Then I ask myself again, what prime number goes into 18? Still 2. So I divide it by 2 again. I then get 9. Okay, create my little tier. What goes into 9? 3. Put 3 up at the top now. Create my little tier. What goes into 3? 3. And I end with a 1 on the top, which I make into my candle. Okay, so that's my goal. So it actually makes a birthday cake. But these numbers on the side here, these are actually my prime factors that are circled in red. These are the numbers that if I multiply back together, it would create 36. Okay, so these are my prime factors. Now, to use prime factors for radicals, we do the same thing. We try to find what the prime factors are. If we have multiples of a number, that's going to be really helpful, because when we multiply them back together, like 2 times 2 actually means 4. 4 is a perfect square that we can pull out of the radical then. Okay? So that's the whole point of this. But let's go ahead and practice them on your own. I kind of switched around your try and your owns because I realized some were better examples that I should walk you through, or some are easier you can do on your own. So just pay attention to the video. but which ones I do and which ones I don't are the ones you need to try on your own. Okay? So let's start with this one, simplify the square root of 42. Yes, you could put it in your calculator, it gives you a decimal, but it does not give you the simplified radical form, which is what you really need to do. Okay? So specifically with square roots, when we do prime factorization, we look for doubles of numbers, because when we have doubles of numbers, they create perfect squares, which means they can be moved outside of the radical. Okay? So we're going to create our little tree, and it's just, or it's not a tree, a cake, and I'm just going to show you the whole cake because for some reason the computer doesn't like me showing you one step at a time. So we have 42, I start with that, and I got 2 goes into 42, so I do that, I get 21. 3 goes into 21, which gives me 7, 7 goes into 7, creating that candle of 1. It's really important that you make sure these numbers on the outside are prime numbers, okay? The order that you choose to put these numbers in, it's totally up to you. So if you saw 42 and you're like, oh, 7 goes into that, do 7 on the bottom. It doesn't make a difference. You'll still get the same numbers on the side here. So it does not matter the order. Now, when we are trying to figure out stuff to pull out of a square root, we need doubles of numbers. Unfortunately, we only have a 7, a 3, and a 2. There's no doubles there. Ugh. So what that means is all these, we can't pull anything out of the radical. So actually the square root of 42 is the simplest form. We would just take all these prime factors and put it back under the radical and then simplify it. So we actually do get the square root of 42, and we can't simplify it any further. We just leave it as is. Okay? Let's try this one, the square root of 75, because this one is a little bit better at explaining what to do when there are doubles. Okay? So the very first thing I'm going to do is create my birthday cake. There you go. So I have 75 on the bottom. I think 5 goes into that. So I divide it by 5, I get 15. Well, 3 goes into 15, so I pulled 3 out. And then I get 5 on the top, 5 goes into 5, creating my candle. Okay? So this one actually does have doubles. They have 2 5s. Now, 5 times 5 is 25. When you take the square root of that, it's just the number 5. So when you see this, when you have doubles, that means that one of the numbers gets to go on the outside. So if you have a pair of 5s, you get to put a 5 on the outside. Okay? The stuff that doesn't have a pair has to stay on the inside. It's kind of like, well, if you get a date, you can go to the dance, but if you don't have a date, you probably just want to stay home. That's not really true, but it's a good way to remember it. So the 5 had a date, so they're at the dance, and the 3's at home under the radical. And that's my simplified form. So that is a simplified version of the square root of 75 because I was able to pull out the square root of 25. Alright? So it's 5 square root of 3. Okay? Sometimes you will have to deal with things other than square roots, like cube roots, which is still the same deal that you're doing, except instead of looking for doubles, because you're doing a cube root, you're going to look for triples. Okay? So that little 3 tells you to look for triples. So I'm going to go ahead and do my thing again. So we got 36. We did this up top too. 36, 2 goes into that, giving me 18. 2 goes into that, giving me 9. 3 goes into that, giving me 3. 3 goes into that, giving me my candle. Again, I'm trying to look for triples. Unfortunately, because it's a cube root, it doesn't have any triples. So the cube root of 36 is the simplest form. I can't do anything else with that. I just put all these prime factors back under the radical and simplify them back together. Now, square root of 36 is a little bit easier. I know that you know what the answer is already with this. However, I want you to practice the birthday cake method. Or if you're going to do the trees, do that first so you can see what you're looking for and see what it comes out to be. Okay? So try this one on your own. Next page. You guys are also going to try this one on your own. So this is a cube root, so you're going to be looking for triples for that one as well. Okay? This one's not as obvious about what goes into it, so you will have to think about it. When you are trying to figure out what goes into a number, use your calculator. Do not try to do this in your head, because if you make a mistake, you've just messed up your whole birthday cake or tree. So use your calculator to check to make sure it actually goes through and what your next tier will be, your next branch will be. Okay? The next thing I need to show you is how to do it when there's variables inside. Well, variables inside is not much different, okay? When there's numbers inside the radical, we just use the birthday cake. When there's a variable, what we do is we just expand out that variable. Usually it's with an exponent, so we just expand it out and write like h times blah, 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 to get it so we can see all the factors. The variables, because we don't know what that number is, each one when we write it in an expanded form, that's basically our prime factorization for the variable. So we're going to do that. Now, if there's a number hanging out on the front, it stays there. It's already been pulled out, it's going to stay out there. So anything else we pull out is going to get multiplied with that number. Okay? So let's go ahead and do the birthday cake first because we're used to that. So 68, 2 goes into 68, and you get 34. So, which I divided by 2, I got 17. 17 is a prime number, so I divided it by itself, giving me the candle. I got a pair of 2s, which means that's going to go out here with the 2 that's already there. Okay? Now for my H's, I wrote them out in expanded form. And again, I'm just looking for pairs. So here's a pair, here, here, and here. So remember, every time you get a pair, one of those numbers gets to go outside. Okay? So I have the 2 at the front that was already outside, the 2 that I found from a pair, and the 3 H's that I got from pairs. The 17 and the other H, they have to stay inside because they don't have a date. Okay? Now once I get that, I can go ahead and multiply the stuff together so I can simplify it, and I get my answer. So 2 times 2 will give me 4. H times H times H, I can write as an exponent. So I get 4H cubed times the square root of 17H. Okay? You guys are going to try this one on your own. Give that one a whirl. And then the last one is for cube roots, just same deal. You're just looking for triples this time. So number, I go ahead and do with the birthday cake, I got 81. 3 goes into 81, giving me 27. 3 goes into that, giving me 9. 3 goes into that, giving me 3. 3 goes into that, giving me a candle. I have a triple of 3s with 1 left over. For my variables, I wrote them all out in expanded form, and I have a triple of B's, a couple of triples of B's, a triple of A's, and the C's by itself, so I can't do anything. So everything that's circled, one of those gets to go out to the front. So I got 3, the A, and the 3 B's that I circled. Now this lone 3, this lone A, and the lone C have to stay under the radical. Do not forget your cube root radical. Okay? And then I can just go ahead and simplify. So 3 times A times B to the third times the cube root of 3AC. And that's my simplified form. To try on your own, very similar, bigger numbers. I also reminded you that there's an invisible 1 right here, so it's really a negative 1 being multiplied with all this. Now, in class, next time, I will show you okay, in my mind, it's a quicker method of how to deal with the exponent part, like the variables part. So you don't have to worry about writing all this stuff out, because this one's going to be it's going to be long. You have to write them all out. Now, you might have been able to figure out a pattern, a trick to help you figure out what gets to go on the outside and what has to stay on the inside. If you figured it out, you are more than welcome to try to use it, and we'll talk about those possible patterns next class, okay? So give that stuff a try. I will answer any questions you guys have next class. Other than that, I will see you later, and have a great day. Bye.